So our next talk will be from Leonie and Mika, and they will talk about interleaving, which is a very interesting topic. So I'm very curious to hear what you did.
Okay, thank you. Yeah, we would like to speak about how we accelerate our iteration speed using debiased interleaving. But before we start into the topic, who are we? We are Leonie and Mika, analyst and product manager for the ranking team on OTTO.de. And OTTO is a full assortment two-sided marketplace. For those of you who may not know OTTO from Germany, so located in Germany, we generate a GMV of 7 billion euros last fiscal year, have up to 35 orders per second, and have 12.2 million active customers and 80 million products on our platform that are currently fighting for visibility on our search result pages. And we would like to start with one quote from Spotify. And Spotify, in a blog post, once wrote, "Product development is a risky business. If you don't evolve your product quickly enough, competitors will outrun you." And that's basically the whole point of why we are here today and why it is so important for us to currently think about how we can fasten our product development cycle. And to make that maybe clear, we normally, hopefully, all start with a user problem. We try to understand and get then into this idea generation. And as a data science team for a better ranking on OTTO.de, then we typically develop a model or tune our model, having offline metrics, and are then always in the cycle of having a new idea how to improve our model and looking at our offline metrics to see if we can now have the hypothesis that we increase the relevancy for our users. And if we are in this product development cycle at the point where we have the hypothesis that we can increase the search relevance, we then typically went into an A/B test. And A/B test for us means we want to detect most like an effect of 1% uplift. We have to wait 6 weeks to see if we have an effect of 1%. And after 6 weeks, we then can decide if we go back to the model development process because maybe our hypothesis was not successful and we didn't see an increase in our online metrics, or we can go further, deploy our model to the customers and tackle the next problem. And 6 weeks is for us a long time. And if we think about the quote, we want to improve in this iteration speed and not have and don't want to wait 6 weeks till we can then decide if we tackle the next problem or go back and try another iteration. So what we tried out is looking at what other companies are doing, and you can find like blog posts or paper from Airbnb, Netflix, Amazon. And this whole approach we are presenting here today is basically based on this debiased interleaving at Amazon search paper. So that's the where the idea comes from and what we try to implement on the OTTO ranking. And how do we use interleaving for us? And what it is, we will tell afterwards and deep dive into it. If we now have the offline model evaluation and have the hypothesis that we have a better ranking for our customers, we will not go into an A/B test. We then will use interleaving for a quicker iteration speed to see if our offline metrics also show that we have an increase in our online metrics. And here we can see that after 48 hours, all the effects are on the same level and don't move so much so that we can have trust into our effects on even lower amount of traffic after 48 hours. And that really helps us because then after 48 hours, we have like a pre-tested hypothesis based on customer feedback if we have to go back into the model development phase or if we can go further and put this ranking into an A/B test, then have 6 weeks waiting time and have the goal of a 100% success rate, because like all our hypotheses are always pre-tested with interleaving, then just going to an A/B test 6 weeks, then we see our hypothesis is proven, so we can then go on into the live deployment phase. And yeah, what interleaving is and how we implemented it, Leonie will tell you now.
Yes, exactly. So you probably all know in a classic A/B test, we usually split up our traffic into 2 equal groups. And then the one group would only see, in the ranking case, ranking A, and the other group would only see ranking B. And with interleaving, this works a little differently, because instead of showing each user either the ranking A or the ranking B, we instead create a mixture in an interleaved list where we present both rankings at the same time. And this follows a specific logic that I will explain later on, but it has the big advantage that we can show 2 rankings simultaneously to the same user. And this has some big methodological advantages, because we're turning the between subject design from the A/B test into a within subject design in the interleaving test. So we're taking out all the variance that exists between the groups, and basically all users are their own control group afterwards. And this, of course, takes out a lot of noise and makes it easier to detect effects. So in the literature, interleaving is reported to be up to 100 times more sensitive in detecting effects. And this is, of course, a big boost for our iteration speed. Like Mika said before, for an A/B test, we usually need a runtime of 6 weeks. And we usually also need all our traffic for that. While in the interleaving test, we only need a fraction of our traffic and have stable results within only 48 hours. So it's a big traffic and time savior, but at the same time, only using a fraction of our traffic means that we have 90% of our traffic left for multiple interleaving tests, for example, but also for a parallel A/B test. So let's look into the logic by which products are placed on a list following the interleaving logic. You can see here the 2 rankings suggested by ranker A and ranker B. And we go through the rankers step by step, and for each step decide which product to place on the list and which ranker to assign it to. So if you look at the first position, you can see that both rankers suggest the same product for the first position of the resulting list. So this is also the product we put there, but it's not assigned to any of the rankers, since they are they're both suggested the same product. If we look at the second position, we see that both rankers suggest different products that are not yet on the list. So we first put the product suggested by ranker A on the list, because in this scenario, ranker A is allowed to start placing products. And this is followed then by the product suggested by ranker B, and the products are also assigned to the respective rankers. Moving to the next position, we see again, ranker A is suggesting a new product. So we put it on the list and assign it to the ranker, but the product suggested by ranker B is one that is already on the list. So in this step, we would just skip ranker B. And going to the last position of this example, it's the other way around. So the product suggested by ranker A is one that is already on the list, so it's skipped again, and the product by ranker B is new, so it's placed on the list and assigned to the ranker. So following this logic, we would fill up the whole list, always asking ourselves the question, is the product already on the list? Is it a new product? And do the rankers agree on the product? Now, this logic has some pitfalls. The first being, as you might imagine, depending on which ranker is starting, the resulting list will look a little different, as you can see here. But that's not the main problem. The main problem is that the ranker starting has, most of the time at least, the advantage of placing the first product. And the first product is, of course, also the one that is the most prominent one from the user perspective. And so, yeah, it's a big advantage for the ranker starting. So we need to take this into account somehow in the way we're configuring our experiment. And for that, we make use of the testing framework that we already have in place for A/B testing. So we didn't have to come up with anything new. We could just use what was already there. So just like in an A/B test, we split up our traffic again into 2 groups. And then in one group, ranker A gets to start placing products, and in the other group, ranker B gets to start placing products. And in the end, when we evaluate the ranker performance, we would, of course, not discriminate between the groups anymore, because we're not interested in any group differences, but only in the within subject effects. So it's just for the purpose of distributing the advantage evenly. Another bias that can happen is an imbalanced list that can happen if the 2 rankers are too similar to each other. So if you look at this example, you can see here that ranker B is kind of always 1 step ahead of ranker A in the suggested product. So even if ranker A gets to start placing products, it only gets to place the first product because going to the next positions, ranker B will always have placed this product already, and ranker A would always get skipped. So in the resulting list, yeah, we have a clear dominance of 1 ranker, and we need to take this into account when we evaluate the ranker performance later on. And this is done with a so-called credit function, because, yeah, not like in a classic A/B test where we just look at our main KPI and yeah, just see whether one group is superior to the other regarding our main KPI. We instead calculate a credit for each ranker with the function you can see here. So we sum up all our wins, and wins could be any KPI of interest for you. So for example, just the number of clicks on the list. And we weight these wins by a visibility ratio to take into account yeah, possible imbalances that can happen. So imagine an example where a user has seen this list consisting of 6 different products, and 1 product was put there by ranker A, and the other 5 products were put there by ranker B. And the user then clicks on the first product on the list, which was assigned to ranker A. Then for ranker A, we would get 1 win because it's 1 click. And this would be weighted by the visibility ratio consisting of the 6 products in total divided by the 1 product that was put there by ranker A. So we would result in a credit of 6 for ranker A in this case. If the user then also clicks on 2 products that were put there by ranker B, for ranker B would be 2 wins, but since the visibility ratio is a little different because the ranker put 5 of 6 products on the list, we get a credit that is lower than the credit for ranker A, even though more products were clicked. So this is the way we're accounting for the imbalances on the list. And in the end, we would just calculate these credits over all users and sessions, and then make a comparison with a paired t-test to figure out which ranking is superior to the other. So coming back to the product development process that Mika pointed out in the beginning, how do we use interleaving in our team? Yeah. Like all teams, we usually start off with multiple ideas for model improvements or for new ranking algorithms. And instead of sending each of these individual ideas into a lengthy A/B test, we instead go into an interleaving phase where we quickly iterate on each of these ideas and then basically filter out the most promising ideas that look good in the interleaving test. And only these promising ideas are then the ones going into the real A/B test, and hopefully in the end also come out with a successful result. All right. So it's really a big time saver for us because we're using interleaving as a pre-filter, but as pointed out in the beginning, it also increases the success rate of our A/B tests, of course. Here you can see a concrete example of how we use interleaving to develop a deep learning ranking model. And you can see that we used 8 iterations of interleaving over a time frame of 8 weeks in total. And with each iteration, we could see whether the new model is still inferior to the status quo and how much inferior it is. And then we can go into the model improvement. And so this way, we basically have an evolution over time of the model. And we would land in iteration 8 at a model that is superior to the status quo and was then ready to go into the real A/B test. So yeah, really a big time saver, because in these 8 weeks, we would have only time to finish 1 A/B test, but here we could do 8 iterations of interleaving. And another advantage, as you can see here in iteration 5, we clearly implemented some sort of bug into our model, and within only 1 day of testing, we could identify the bug and fix it and go on with the model improvements. Okay, and with that, I give back to Mika.
Okay, thank you. Now we have some problems that we didn't tackle now, and we would like to point them out. So the first thing is, if you have a look at these numbers, and if you look at, we have the +2 to up to +8% in interleaving, like it would now be the goal that this is the A/B test scenario, right? So we want to see that if we have something tested interleaving, that this will also be good if we test it in A/B tests. So what we do is, like, we correlate our interleaving tests with the A/B test results. And if we have a look at our different metrics we are currently looking at, like, we are not there right now where we can see that we have like the perfect correlation between our interleaving metrics and our A/B test metrics. So we are currently having like some problems still seeing this a high correlation between interleaving and A/B test. And there is still room for improvement. So as an example, if we go back to the 2 rankers, ranker A and ranker B, you can imagine if a user clicks on this green shirt, you can question yourself if you would have the hypothesis that a ranker, in this case, it's the credit is given to ranker B, will be better if we then do an A/B test between these 2 rankers. And probably you would not have the hypothesis that if all users just focus on this green shirt, interleaving would show us that ranker B is superior to ranker A because all the credits will go to this ranker. But in a real A/B test, there is no big difference between the 2 positions, and probably users in group A will also find their green t-shirt like the user in group B. Other way around, if every user just likes this, what is it, salmon colored shirt, then in interleaving, all the credits would go to ranker A. And if we have a look into the differences between the positions, you now may have the hypothesis that placing this product on this position is better. And so ranker A really will be better in a real world A/B test afterwards, because this position difference between position 3 and position 50 really matters and will have an effect in the upcoming A/B test. So what we are currently doing is we track the position differences between these products in our tracking, and we then try to integrate the position differences in our credit function, so it will have a bigger influence if there is a bigger position difference and not such a big impact if there are just small differences between the position. Also, there are other problems, and we really we're trying to have like example of how you can rethink about what interleaving is and what A/B testing is, and we really like to have this comparison between the classic 11 versus 11 football match and the penalty shootout from a football match. So yeah, you basically can say that there are other problems if you think about the comparison between the classic match and a penalty shootout, because one problem is the player by itself decides the outcome. So if you interleaving just places products based on the product performance, but if we have diversity hypothesis or thinking about having pairwise, listwise rankers, you may think of interaction effects between these products. But you can see these interaction effects with interleaving because it's just about getting information about which product is better than another product. Same like in penalty shootouts where one product just tries to score a goal, penalty shootouts, yeah, and not in a classic football match. Also, the score doesn't represent the classic outcome. Like you saw our iterations of minus 80% that are not like real minus 80% in units, and also they are not like real up to plus 8% in units. So we overestimate our effects with interleaving. So we can see if there is one ranker is superior to the other ranker, but we can't interpret like the effect sizes. Like in a penalty shootout, there are also like high outcomes. It doesn't represent like the classic football match outcome. And to summarize like the everything we learned about interleaving, we see that interleaving is more efficient to get the results. Like we see 48 hours and we have stable effects between in comparison to the 6 weeks of A/B test results. But like the classic match is still closer to the reality because we are not there that we have really high correlation between interleaving and A/B tests. And we don't want to get interleaving to replace A/B tests. We just want to interleaving to like pre-test our hypothesis. It's never our goal to say, okay, we don't want to go into A/B tests in the future. Our goal is just to iterate faster by filtering our ideas. And that's where we are currently, like using interleaving for filtering out like really bad ideas at this point, and still have a look at ideas that are close to getting better. Yeah, and that's where we try to get better in interleaving and how we use it currently. So yeah, at the end, a big shout out to Andreas Wagenmann, who's sitting there in the 4th row. He worked for us at OTTO for the last 18 months and came up with the idea of interleaving. So if you are searching for a freelancer, he's a freelancer now, you can reach out to him. He has a lot of good ideas, even besides of interleaving. Yeah, so reach out to him. He's here and speak with him. So thank you all for this presentation, for having a look at us with our interleaving learnings. And if you have any questions, reach out to us.
Thank you very much. Questions?
Now that you have that many comparisons, like on the with the variants on the interleaving, have you considered also making the offline evaluation more robust, like looking for ways how to actually speed up the process upstream?
Yes, like in a perfect world, like we maybe not even need interleaving because we have the perfect correlation between our offline metrics and our A/B test, but that's not where we are right now, and we are even not so close to be in this correlation. So we are always like comparing the effects of offline correlation, offline metrics, interleaving, and A/B tests. Yeah, so the goal is to get better there.
So did you find there was like something missing in your evaluation that would improve the correlation? between offline evaluation to interleaving to A/B test?
We didn't go into this step at the moment.
Okay. Yeah. Great, thank you.
Very interesting talk, thank you. I'm at OpenSearch and we have interleave testing on our roadmap for our relevance workbench. So all of the things you've learned are very valuable. One thing that we tend not to talk about in these meetings, we like to show the numbers and the objective reality, but I was wondering more about your subjective human understanding of what's going on. So I'm sure you've looked at some of the results. Why did this interleave test not predict the A/B test correctly? Or why did the offline testing not correlate and so on? What are your insights about the, let's say, subjective differences or the not easy to measure differences between things? I mean, the kind of thing I'm thinking of is perhaps queries which have some unique number in them. I have a part number, ABC123, the interleaving is useless basically. That kind of thing. What have you noticed?
Actually, there are no real learnings I can share here because, yeah, we have a lot of we have full assortment marketplace with a lot of different queries with a lot of different query types. If you think about I don't know, attribute based searches where you type in, I don't know, 6 inches or centimeter or so on. We have different hypotheses for different query types, but we are not at the point where we have learnings based on we saw offline rankings compared to interleaving rankings and then thought, okay, we always see the same thing between offline evaluation and interleavings. There unfortunately is no learning we can get up here.
Let me encourage you to be more eyeball results. But it's surprising sometimes to see things that don't see the numbers. Like, oh my God, obviously if there's a spelling error, then this test is more sensitive than that test or whatever.
Okay, yeah, thank you.
One question on personalization. It was always the weak point of A/B testing because you're splitting users. They have different profiles. So what are you testing comparing? But interleaving opens the possibility to testing personalized search. Do you personalize at OTTO? Do you have tips for having scientific approach to interleaving when you personalize results? Or is this something you have not looked at?
Yeah, we're currently at a step where we are really deep into segmentation and trying to cluster different user types, and we are using interleaving there also and see that it really helps us to iterate because there are a lot of ideas on different clusters, and I think there are infinite of the ideas of how to cluster users. Interleaving really is a game changer there for us. Yeah, but our problem maybe into this segmentation thing is probably that all interleaving tests currently, we are not at the stage where we have the hypothesis that something is better in an A/B test. We had it once now and we saw that it correlates with interleaving, but was not we can ship it to the users now. So that's basically where we are there right now, and we use it for segmentation, personalization, and so on.
Nice, that's very promising. Thank you.
Yeah, thanks for the presentation. My main question was, why did you choose balanced interleaving? Because it's known to have all these issues, and there's other ways of interleave, like the, what was it, team draft interleave, probabilistic interleave, optimized interleave, and especially the step from balanced interleave to team draft interleave is really small. Instead of flipping one coin, who goes first? You flip one coin every time you need to pick a pair. So, what made you choose this one?
Well, basically, it was just a starting point for us, and we're not at the finishing line yet. So we're trying out different things that work for us. And regarding the who gets to start, it was the easiest way to just use our framework that we already have. And we also validated that we don't have see any weird things in the data due to the way we split up our traffic right now. So right now we don't have any reason to.
Thank you. So we'll have a break and we'll start at 11:30 then.